Hey, it's Dr. J. Today we're going to do 1.4 and 1.5, multiplication and division, and this should be the end of the introduction. Chapter 1 will be in the record books after today. So we'll start off with multiplication. Multiplication are also called products. Using mental math, just like we did in the last example, you should know all the products from 2 times 2, 2 times 3. You should know all your products all the way up to 12 times 12. And when I say no, I mean you don't really have to think, right? If you have to think, then you don't know, right? So if I say, 8 times 9, if you have to stop and think about it, you don't know that it's 72. In my classroom activity, we do a timed exercise where I have you do them all in less than 3 minutes. So it's a power drill. Try to get through all the products in less than 3 minutes. Unfortunately, with this format, it's very difficult for me to time you because I don't know how long it's actually going to take you. So I'm just going to leave that as a DIY. Do it yourself. You'll know whether or not you can do it or not. I guess I won't really know. We'll just have to leave that as a trust exercise between us. In this lesson, I'm going to assume that all the products up to 12 times 12, that you know them very quickly. Although you can probably get away with up to 10 times 10 because, the 11s and the 12s are the ones that, some people might be a little rusty on. I'm going to go ahead and just start doing the examples, starting with numbers larger than the ones that I think, you knew when you were little. I'm also still using the old-fashioned multiplication symbol. Oh, come on. Come on back to me. I don't know what I'm going to do about this camera. So let's do some, 2-digit multiplication. What's 53 times 8? Hopefully we can get some focus going on here. Focus. Come on, focus. There we go. So multiply 53 times 8. If you're really good at mental math, then you already know the answer. It's, 424 or something. So mental math is usually not very easy with larger numbers like this. So we're going to use the stacking method. Typically, we put the smaller number on the bottom. So 53 times 8, we do 8 times 3, which is 24. Carry the 2. And then 8 times 5 is 40, plus 2 is 42. So the answer is 424. Okay. You can also use the expanded method. This is how typically we do it with mental math. If you really want to try mental math, the expanding method is really good. You expand the larger number typically. So the larger number is 50 plus 3. Yeah. And then you use the property of distribution, which we'll get more into in chapter 2. So you've got 50 times 8, and then 3 times 8. And you can do all this in your head. 50 times 8 is 400. 3 times 8 is 24. And you're still going to get the same answer of 424. So the expanding method is using the expanded form of what 53 actually means. It means 50 plus 3. Yeah. That's essentially what you're doing when you multiply here, right? You're going 8 times 3 is 24. There's the 24. And then you're going 8 times 5 is 400. And then you're adding those together. Either way, it's fine. Don't use your calculator or your phone. And again, it's a trust exercise. I could also say find the product. Find the product of 72 and 29. So product means multiply. Turns out you don't have to put the larger number on top, but it just looks nicer. It makes it typically easier, especially when you get much larger numbers. So we're going to multiply 9 times 2. That's 18. Carry the 1. 9 times 7. That's 63, yeah. Plus 1 is 64. You need to put a placeholder. You can either use a 0 or you can just use a blank and just leave a little blank spot right here. It's up to you. Most people use a 0. I have seen some people use an X because you're multiplying, you know, an X placeholder. And now you're going to move to the next digit. So 2 times 2 is 4. 2 times 7. Now remember, the carried 1 from before has already been used. So 2 times 7 is 14. And then now you're going to add these together. So you get 8 plus nothing is 8. 4 plus 4 is 8. 6 plus 4 is 10. Carry the 1. 1 plus 1 is 2. And so the answer is 2088. Let me check the next one. They get worse, example 3, or they get better depending on how you're doing it. Multiply 278 times 316. All right, so I like to put the smaller one underneath. Okay, that's my multiplication here. Now this one's going to take up a little bit more space. The number of rows is always equal to the number of digits in the bottom number, which is typically why you like to put the smaller one on bottom, because you just get less rows. These both have 3 digits, so it really doesn't matter which one we put on the bottom. So 8 times 6 is 48. Carry the 4. 8 times 1 is 8, plus 4 is 12. Carry the 1. 8 times 3 is 24. 24 plus 1 is 25. Put a placeholder. Move to the next digit. Remember, your carries are done now, so those are no longer there. You're going to have a new set of carries. 7 times 6 is 42. Carry the 4. Oh, it happens to be a 4 again. 7 times 1 is 7. Plus 4 is 11. Carry the 1. 7 times 3 is 21. 21 plus 1 is 22. Make sure you line these up. If you get sloppy and you do stuff like this, it'll screw you all up because, look, you'll be not lined up. So you have to make sure that every column contains only 1 digit in each column. Of course, each row and column. You don't want to be offset a little bit. When you get to the 3rd digit, now you have to put 2 placeholders. 2 times 6 is 12. Starting over again with a new carry. So carry the 1. 2 times 1 is 2. Plus 1 is 3. And then 2 times 3 is 6. And now we're adding in columns. So 8, 0, and 0 is 8. 2, 2, and 0 is 2. Oh, no, it's not. It's 4. Just testing you. 5, 1, and 2, that's another 8. 2, 2, and 3, that's 7. And 2 and 6 is 8. And so there's your answer. This is what we call the result. Okay. A good application of multiplication, the main application, is the area of a rectangle. Yeah. So we have length and width. Man, the focus is really bad today, isn't it? Come back to me. Come back to me. I'm going to feel like I'm going to be doing this all day. Here we go. Come back. Well, anyway, while I'm waiting for the focus to come back, looks like it's just going to be one of these days. Sometimes this is called base and height. All right. Or you can just think of them as sides. Yeah. Side, side. You know, side A, side B or something, you know. But the way we typically memorize it is area is equal to side multiplied by side or length multiplied by width. There we go. I knew it would come back. So this is the way we typically memorize the formula. However, we sometimes change the words. We might say, you know, side A times side B, or we might say base times height. Some people will say height and width. It really doesn't matter what you call it. Tomato, tomato, tomate. Right? There's lots of different ways, although this is the way we typically memorize it. So remember, area is not the same as perimeter. Area is the inside. Think of it like a rug, you know, how much actual space is inside of it. Should we do one? I think we should. How many square feet of carpet is needed to cover an area that is 12 feet by, let's cover a rectangular room. I'm going to make sure I say it right. That is 12 feet by 18 feet. I'm going to use the word area in a minute when I'm done with it, but right now I'm talking about a rectangular room. I could have just vaguely said area, and then, you know, the real stickler out there could go, well, how do you know the room is a rectangle? Well, we're assuming in this section that we're talking about rectangles. All right. So by, the word by in algebra and geometry and math in general means multiplication. We can ignore the feet for now, and we can just multiply 12 times 18. You could try that with mental math. I didn't memorize my products up to 18, but I do know 12 times 12, and I do know 6 times 12. So 12 times 12 is 144, and 6 times 12, 72. Yeah, so I've got 144 plus 72. Let's just go ahead and put that under here. So you're going to get 6, 11, and 2. 216 square feet. That would be the area. The abbreviation for square feet is FT with a little 2 up here. FT squared. It looks like FT to the second power. I will notice that this is just an abbreviation. I do not actually want you to now square the final answer. I can't tell you how many times I've taught this lesson and then had somebody get the right answer, and then they'll see the FT squared and their brain goes, oh, now I have to square it. And then you'll end up with just a ridiculous amount of carpet, you know, and way more than you actually need. So 216 square feet. It essentially, if you think about it, it kind of means that if the room looked like this, you could fill it up. I'm not really going to do it, but you could fill it up with 216 little squares. I would be here for an hour if I actually tried to draw 216 squares, so just use your imagination was all. If carpet came in little squares, kind of like tiles. It typically doesn't. It typically comes on a giant roll, but I think there's probably square carpet out there somewhere, right? They look like tile, but they're carpet. Another example is pixels. Pixels on a computer screen. All right, so instead of little tiles, your computer screen is comprised of a bunch of little dots called pixels. All right, so you know your phone screen or your television screen or your laptop screen is comprised of pixels. 540 rows and 810 columns. Yeah. So the rows go this way. So you've got 540 rows, and then the columns go vertically. Just think of the column of a building or a column of I guess I don't know another word for a building. All right, so we're going to have 540 times 810. All right. You want to know a little trick? All right, it's a nice trick. Both of these numbers end in 0. Yeah. So that means that I'm going to have 2 rows of zeros. Yeah. So instead of going 0 times 0, 0 times 0, 0 times 0, and getting that, I can just automatically put down my 2 rows of zeros. And now I can ignore them, yeah, and just multiply. I don't know if you can see that. Just multiply 81 times 54. So 4 times 1 is 4. 4 times 8 is 32. 5 times, so I'm kind of going like this. 5 times 1 is 5. 5 times 8 is 40. And now I'm going to bring down those zeros. Bring down the 4. 2 plus 5 is 7. 3 plus 0 is 3, and then 4. And so it would be 437,400 pixels. The entire screen. That's how many dots. That's a lot of little dots. Yeah. All right. If you don't like this trick, I don't require that you do it. It's trying to save you a little bit of time. You could do it all out the long way. 0 times 0. 0 times 1. 0 times 8. Put a placeholder. 4 times 0. 4 times 1. 4 times 8. Put 3 placeholders now. 5 times 0. 0. 5 times... Hold on. No, I got screwed up. I think my trick is better. 0 times 0, 0, 0, good. So it's only 2 placeholders. That's the problem with all these extra placeholders. So now you got 5 times 0 is 0, 5 times 1 is 5, 5 times 8 is 40, and then you add in columns, keep everybody lined up, and you should get exactly the same answer. So 437,400 pixels. Sometimes the area is not an exact rectangle. And there it goes again. Come back to me. Well, we'll wait for it to come back. So find the area. So we've got, let's see, 3 meters, 11 meters, 7 meters, and 2 meters. M is meters. I don't know about you, but this is driving me nuts. Come on. I wish there was a button I could press that would just set it back to normal. Come on. Come on, come on, come on. All right, well, I know it's a little blurry, but I can't wait any longer. So we got 2 meters, we got 7 meters, we got 11 meters, and we got 3 meters. It turns out that we don't really need the M's. All right, we're not going to include the M's in our calculation. Ah, there it goes. All right. And so we need to dissect it into 2 rectangles. All right, so you have a choice. Yeah. Choice 1 would be to cut here. And so now you've got this rectangle, this tall, skinny rectangle, plus this long, wide rectangle. And then you need to figure out how long everybody is, right? So let's see. In choice number 1, I would have 7 meters and then 2 meters. So this rectangle would be 14 meters. All right, 7 times 2. Okay, but now I have to be careful, all right? This 2 is the same as this 2 here. So that means that this side is 11, but I've already cut off 2. I cut off 2, so that means now I only have 9. This side is 9. And then this side is 3. So the area is 9 times 3, which is 27. Okay. And then the total area is 14 plus 27, which is 41. So the area would be 41 square meters, or 41 m squared. That would be your first choice on how to cut it. We already have the answer, so I'm going to tell you the second choice, but I'm not actually going to do it. I just want you to know that you have choices. Your second choice to solve this problem would have been to cut here. Let me just put everybody back. So this is 2, this is 7, this is 11, this is 3. So choice 2 would have been to cut here. And so now you've got this little rectangle plus this big rectangle here. which is 11 by 3. So in this case, now the big one's already done. 11 times 3 is 33. But now the smaller rectangle, I don't know. I know that this side is 7. And I know that this side is 3. So if you bring this 3 over here, yeah, then you know 7 minus 3, and I know my drawing is not quite to scale, so this side would be 4. Yeah, 7 and 3 would be 4. If I really wanted my drawing to look good, I'd have to go like this and make this look actually like 4. So this is 4. Yeah. And this is 2. Yeah. And so the area here is 8. And I should still get 41. And I just said I wasn't going to do it, and I ended up doing it anyway. You'll get used to that. It happens to me all the time. Okay, next we're going to do division.